Well, all right, welcome to another sad video. I have to throw away some of my old prototypes. So today I'm going to be throwing away this thing right here. So when I was in grad school at MIT's Media Lab, one of my major projects was something called the exertion music or the electric eel instruments. This was a system of making music, a bunch of music instruments that got energy, electrical energy, from little generators. So you go like this. Every time you back drive that motor, you make a little electricity available at these terminals to drive a computer and an amplifier, etc. And once I discovered this principle, I spent a lot of time with different physical forms trying to get correspond the way the body moves to making music. So for example, this one was supposed to be a little bit like a snare drum. You go bam, 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 bam. You see there's some elastic bands there. There's a hub that attaches it to a motor. And here's your wires. So they all have different efficiencies and such. This one is interesting because it used a, so you have this bar that you hit like this. And I wanted to put it on an elastic mechanism so it would return. I think the holy grail for me, well, there are a lot of nice instruments I made, but one that I really wanted to make was a piano key that you could just kind of hit like that and it would return and give you just enough energy. So this was one of those, and you see it uses this large gear and that small gear there. And, you only have so much time in the dissertation, so and in building these instruments, there's a lot that goes into it. It takes a lot of time. So I could only build so many of these into instruments. So I'm going to keep all of these generators that pass. This is my electric eel shelf here. It's got all the different parts. Oh boy, this is one really, really bad generator. It's one of those toys where you squeeze the trigger and it spins the thing on top. That's one of the first ones I tried. It was very terrible. And I'll throw this away someday, but I'm not ready to part with that yet, because there's a lot of interesting pictures and experiments. That's an early one. This one was a late one, and it was never fully working. The idea here was that you would hit this wheel kind of like that other one I just did, this one here, except I wanted more power by spinning this stepper motor even more. So I thought I was going to put a belt here and wrap it around and stuff. You'd go. The only problem is I discovered that you can only have a certain amount of torque when you hit this. What that means is you can only push so hard on one of these generators. So for example, this one here is just light enough that you can kind of go back and forth with it, let it spin out a little bit. This is a very expressive one. It gets the expressivity through not only the mass, but the moment of inertia of this plate. So the moment of inertia, as you know, is different from the mass because that's it's basically the torque required to get something spinning. So one interesting thing is that mass on the outer diameter counts more than on the inner diameter. So with this one, I drilled a whole bunch of holes in there, actually laser cut them, so that most of the mass was in the center. But I extended it out because I found that the diameter or the radius of this spinning wheel matters quite a bit. Why? Well, because if it's very narrow and you try to hit it, then you're not going to have much contact time between your fingers and the thing that you're trying to play. So it has to have a certain diameter. So let's look at this other one here. This one has a huge diameter, and you can also see it doesn't have much mass in the center. So this one you can kind of go like that. It's got approximately the same moment as that one. I didn't actually calculate it or measure it, but I could just tell by the feel how long it takes to accelerate it given the force. This is nice because it has a long contact time with your fingers for every movement that your body does. Let's see. I think optimally it would be a little bit smaller. I honestly think that this one is about as optimal as it gets. And that brings us to why I'm throwing away this one. This is extremely suboptimal for a number of reasons. And I'm going to talk about why I decided to just hang on to this for so long, even though it was a failure. So first of all, I couldn't really admit that it was a failure for various reasons. I think I was very much hung up on the idea that I wanted to try a broad range of things and learn from them. And I never really had a good idea in my mind of what it would look like that day of learning. When I did the dissertation, I went through and I looked at my 6 most successful generator prototypes, and I measured them electrically, and talked about how their movement affects the sound and things like that. For example, some are very sharp, which makes like a drumline sound, sound. Others you could spin for a long time, etc. But a couple of them just never made it because of the constraints of the dissertation. So I finally, I never had a day when I was just going to sit down in my own lab and do all this. So now I'm doing it one at a time. So that's why this one kind of survived so long. So let's talk about the problems. First of all, this mass is kind of heavy. You can see when I hit it, it goes for a long time. Maybe that's a little bit desirable for a certain kind of instrument. I never really got into those, and maybe this video is going to be a reminder to actually make some like that, where you hit it once and it lasts for a long time and makes a long resounding note. I never got around to doing that because I always wanted things that you could play rapidly, like do 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 do. I never just wanted a gong like bong. I wanted to play melodic music, not even just like art music where there are random parameters. But a problem, so that's problem one, is that the mass is really high. And why is the mass so high? Well, because look at this. First of all, it's got 3 pieces of acrylic. It's got these flanges meant to keep a belt in there. It's also got a big heavy metallic shaft. It's got a 1/4-inch steel there, and that adds just a little bit of bulk. And then of course it's got the heavy acrylic there that's like 1/4 inch, and it's completely solid. So you add all those things up, and then it's also got this hardware hub holding the shaft onto the disc. So you add up all those things and it just becomes a lot of mass. So that's heavy as heck. And then the next thing I wanted to do was turn all this motion and drive this motor here with a smaller gear. So what would that do? That would just increase the amount of torque that it would take to drive this. Sure, when you move this an inch, it would spin this like a whole rotation and give you a number of joules. But it's got to be like an effort to go like, Urgh! And I mean, I know the project was called Exertion Instruments, but maybe not that much exertion. And so maybe it could have been built into something where you hold onto this firmly, and this thing is firm, and you do some notes here, and you go, Urgh! 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 But I just don't think that's like the side of the design that I was really so much interested in, and maybe I still could down the line. But for now, I don't think this is going to be useful in the near term. See, I'm starting to regret this just thinking about it. Because I'm like, oh, I didn't explore that section yet. Well, look, if I ever get the impetus to start experimenting it, I'll look at this video, and I still have all the CAD files for this thing. So let's just talk about another aspect of this, which is why I didn't want to get rid of it. First of all, I just think this was so well engineered. Not from like the forces, but as far as like the mechanical of making this thing solid. You see, I'd spent a lot of time, I was totally in love with the laser cutter, learning how to use the laser cutter to make things like that. And I came up with this specific H trestle shape here. And it just happens to be, this is an extremely rigid member. So if you watched one of my other videos where I got rid of one of my electric eel bodies that was used in a workshop, one of the workshop members suggested to me that I make a kind of vertical shape that was just one of these members, and I later expanded that. I widened it, and then I hollowed it out, and then I put the X in. So it took a few stages. You see how it's got those pegs in there, and I think this is all just press fit, meaning if I pull this apart, well, maybe it's in there so tightly. Oh yeah, there we go. See, that's in laser cutting, it's really good to adjust your kerf just right so you get a good press fit like that. So I was very proud of this thing. The other thing I was sort of like overly proud of was that I used ball bearings in it. Ooh, I know mechanical engineers are like, big deal. But for me, as kind of a software guy, like learning to do some basic mechanical engineering so I could build these things, that was a huge deal to me. So you put that together, and I think I also, I was just kind of proud. I was also proud of this hub thing that I made that could just connect shafts to all kinds of discs, and because it was very important for me to connect. I was experimenting with a lot of different motors to see what kind of motors would be best. What voltage speed curve, what internal moment of inertia. which impedance, real and uh, imaginary impedance, everything like that, what size, all these different parameters. So I really wanted to attach all kinds of different discs and things to all kinds of different motors. That's why I made these hubs. Super useful. And I suppose I still have the CAD files for it. If not, I guess I could recreate this design pretty easily. It's just two halves with screws going that way and screws going that way. And these two clamp onto the shaft, and then the other two mount perpendicular to whatever you've got. So, let's see. I was just really proud of this thing, Marie Kondo's whole thing is don't keep something if it doesn't spark joy. Well, I can tell you for maybe the 4 or 5 years that I've had all my generators up on this shelf, they really do spark a lot of joy for me. So I don't think that works as the best test to determine whether or not it's time to get rid of something. I mean, it helps, don't get me wrong, it's not garbage, but in this case it was really kind of keeping me stuck because I just enjoyed that joy. I got that reinforcement all the time. But the thing is, time has moved on and I'm making new generator types and I'm making new instrument types and doing new kinds of music instrument projects. And I've got to make space for it because my whole apartment is just like full of prototypes. So really got to bring in the new and let go of the old. So I'm going to get rid of this. I'm going to make a little more space up here. I'll probably never get rid of something like this. And that's mostly because this is actually useful. Like this one works well. See, that's another differentiating factor. Like that works and you can put it in instruments and it's fun. This one never worked and it could be made to work, but I'm not about trying to make that type of thing. I've got, all these other objectives with the instrument projects and, you've seen some of the videos online and I'll be making more. I'm trying to make nicer looking bodies. I recently am upgrading the CPU. I've got a more efficient amplifier. I'm putting larger keyboards on the things, giving them more knobs. All these other projects, and I've got a couple generator types that are really the best of breed. And so that's what I'm doing. So it's time to let go of this. And I'm going to just do it fast while I've had my cup of coffee and I'm really feeling it because I've thought about this for a long time and changed my mind a bunch of times. But it's time to just disassemble and let go.